What if I told you one machine costs more than an entire neighborhood? No joke. This engine alone can be worth over $30 million. And here's the crazy part. Every single piece inside it has to be almost perfect. Even a flaw smaller than a human hair can destroy the entire engine. So, how on earth do engineers build something that survives temperatures hotter than lava while spinning thousands of times every single minute? Today, we're going inside one of the most expensive manufacturing processes on Earth. And trust me, we're just getting started. It all starts with a metal that's insanely strong, yet surprisingly lightweight: titanium. But digging it out of the ground, that's just the beginning. Turning it into aerospace-grade metal takes weeks and costs an absolute fortune. Then the metal is melted at temperatures so extreme, regular steel equipment would literally melt first. That's why manufacturers use massive vacuum furnaces, removing oxygen before the metal is even formed. One tiny contamination, and the entire batch gets scrapped. Now you'd think the hard part is over. Not even close. This is where precision goes absolutely insane. Every turbine blade is carved with tolerances measured in microns, thinner than a single strand of your hair. Miss that target, and a multi-million-dollar engine could fail. And believe it or not, we're still nowhere near the hardest part. All right, this is where things get absolutely insane. You'd probably think these turbine blades are forged like any other piece of metal. Nope, not even close. Most metals are made up of millions of tiny crystals, but these blades, they're engineered to become one single crystal. Sounds pretty much impossible, right? Engineers actually grow the blade inside a ceramic mold, almost like growing a crystal in a science lab, except this one's worth thousands of dollars. The metal cools painfully slowly, so the atoms line up perfectly. If they don't, game over. That blade never leaves the factory. So why go through all that trouble? Because a single crystal blade can survive temperatures that would destroy ordinary metal in seconds. But here's the really crazy part. Even these incredible blades still aren't strong enough on their own. So engineers cover them with a ceramic coating, basically a high-tech heat shield, just a fraction of a millimeter thick. That paper-thin layer helps protect the metal from temperatures pushing 2,700 degrees Fahrenheit. Hot enough to melt a whole lot of metals. And then, engineers use lasers to drill hundreds of microscopic cooling holes. Each one is thinner than the tip of a pencil. Those tiny holes create an invisible blanket of cool air, keeping the blade alive inside an absolute inferno. And believe it or not, the engine still hasn't even been assembled yet. All right, now comes the moment every engineer has been waiting for: assembly. But don't picture your average factory line. This is on a whole different level. Every single part has a digital identity. From the first bolt to the final turbine blade, engineers know exactly where it came from, who made it, and when it was inspected. No guessing, no shortcuts. If one component can't be fully traced, it doesn't go into the engine, period. Next comes one of the toughest jobs: stacking hundreds of precision parts together, with tolerances measured in microns. Think of it like balancing thousands of spinning puzzle pieces, except they're moving close to the speed of sound. Even being off by a fraction of a gram can create violent vibrations powerful enough to tear the entire engine apart. So engineers use laser-guided balancing systems, adding or removing microscopic amounts of material until the rotor spins almost perfectly. Now you'd think, after months of manufacturing, the engine is finally ready to fly. Not even close. First, it has to survive one of the toughest test programs in all of manufacturing. And trust me, what happens inside that test cell is absolutely unbelievable. That's where millions of dollars are either proven or lost. This is it. Months of engineering, billions of dollars in research, all come down to one moment: the first engine start. The room shakes. The turbines begin to spin, slowly at first, then faster. until they're moving at thousands of revolutions every single minute. At full power, air rushes through the engine at unbelievable speeds. Inside, temperatures climb to well over 2,500 degrees Fahrenheit. Hundreds of sensors track everything: temperature, pressure, vibration, fuel flow. Every single millisecond matters. If anything looks even slightly off, the test stops immediately, because one failure could cost millions of dollars. But passing just one test isn't enough. These engines are pushed through freezing cold, scorching heat, heavy rain, and even simulated bird strikes. Yeah, they actually fire specially prepared birds into the engine during certification tests to make sure an aircraft can keep flying safely, even after a bird strike. After weeks of testing, engineers take the engine completely apart, looking for wear, microscopic cracks, or anything they didn't expect. Only after passing every inspection, every stress test, and every performance check is the engine finally cleared to fly. So the next time you board a plane, remember, you're looking at one of the most advanced machines humanity has ever built. A masterpiece that took years to design, months to manufacture, and millions of dollars to perfect. Pretty incredible, right? If you love seeing how the world's biggest machines are built, hit subscribe, because trust me, we've got a whole lot more coming.